All right, guys. Before we get real into this, let me get your attention. Basically, all this says is big scary warning. Can't have a cybersecurity talk without a big scary warning. I'm not really a professional. All of my information is factual research, blah blah blah. But that doesn't mean it's best practice or industry standard. So if you are more knowledgeable in security than I am, and you hear something that I say and it's like that's not quite right, it's not supposed to be. This is a very base level introduction. If you've never done or seen anything in security, especially if you're just a game developer, I've never even thought about it before, this is for you. If you're in security already and have delved way deeper than I ever have, all this information is not going to be new to you, and it's probably going to be pretty boring, so that's just a little heads up. So, one more disclaimer. Got some pretty bad jokes in here, some pretty dank memes. Bear with me. That's my only pun, though. I promise that's my only pun. No questions. So, let's get in. My name is Casey Erdmann. My talk today is called Cheat Codes. I'm talking about cross-site scripting and game exploitation. So, a little bit about me. I'm a software developer. I work for a local company here called Tracksoft. I do mobile app development and website development. And actually, just recently, I started doing some cybersecurity work as well, so that's been pretty fun. I also publish software under my own project called Injection. I write various iOS apps, Android apps, just anything I feel like writing that I think is worth publishing. I use this little organization platform I've made to go through there. I am a huge security enthusiast. I love studying about security. I love trying new things with security, being, whether it's web exploitations, trying to break applications, any kind of fun stuff like that. I like learning about how that stuff works because I believe it makes me a better programmer. If I can write more secure code because of my knowledge in security, I think that's very helpful because I love developing software, and security is a big plus in that. CTF connoisseur. For those of you who don't know what CTFs are, they're capture the flag events for cybersecurity. You go in, typically if it's a physical event, you can have online events, but my favorites that I've been to are the physical ones where you go into some hosted event. They have all these networks for you to set up all these challenges, and what you do is you break into this Wi-Fi network to find this flag, you sniff the network to find a packet, you break this program, you break into this website, blah, 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 to try to find a flag to get points to win to get the top. And normally if you win, you get some cool prizes. And they're just a lot of fun. Some fun facts about me. We are at a gaming conference. Sonic Adventure 2, best video game of all time. Don't care who you are. Get at it. And that last little one's a jab at my little friends who like Windows there. Windows is not really good for anything but games. All right, so what am I talking about? Yeah, sorry, the first meme. I'm talking about cross-site scripting. I'm talking about reverse engineering, and I'm talking about hacking games specifically on iOS. So cross-site scripting, what is it, yo? So cross-site scripting is basically, like very base layman's terms, is running code on a website that shouldn't be run that affects multiple users. So for those of you who don't really understand how websites work, whenever you go into a website, enter whatever URL, Facebook, blah, 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 you have a session. That session is unique to you. All the code and everything that you see on that session is just for your session. If I can execute code that affects your session, that's cross-site scripting. So we're going to start with talking about that. So you guys are video game people. You don't make web apps. You don't do anything like that. Why do you care about cross-site scripting? Well, a lot of web-based platforms are vulnerable or can be vulnerable to cross-site scripting. This is whether you're a consumer of video games or whether you are a game developer trying to sell your game on a platform. These e-commerce platforms like Steam, Origin, Microsoft and Sony platforms all have the potential to be vulnerable to cross-site scripting because you buy these games online. And even physical platforms where you buy physical games like Amazon.com or GameStop or whatever, these are all web platforms where you're entering your credit card information to some kind of website. If they have a vulnerability, it affects you, whether you made the site or not. So just because you didn't make it doesn't mean it doesn't affect you. Okay, so I'm going to do a little demo about cross-site scripting for you guys. A little disclaimer before we get started here. If you have done cross-site scripting before, I am taking you into an environment. This is very interactive. So if you have a phone, laptop, or computer, get that out now if you would like to participate. I am injecting code onto your phone. It will not be malicious, I promise. It's just for demonstration. But if you have experienced this prior, please wait until I'm done with my demo to do anything. Once I leave, I don't care what you do, and everybody who stays, you're at your own risk. But I do want to show this to you guys. So I'm going to show you how to identify cross-site scripting vulnerability, how to exploit it, and then after I'm done doing that, I'm going to show you how to prevent it. All right, so if you want to participate, any web browser, any phone, please visit this URL. It's xss.injection.org. Injection, it has a 0 instead of an O in it because domain names. And I'm going to give everybody a second to get that. I'm going to tell you about this little application that you're logging into. This is an app called Cougar Chats. My friends Aaron and Frank made this for their software engineering project. And the night before they went to present, they had our group of friends go in on it and do just a test on it, see if we could break it. And the first thing me and my friend Nate did were try to find cross-site scripting vulnerabilities, and boy, did we find them. And we just started blowing up the chat with all kinds of stuff. So it's pretty fun. So if you're there, go ahead, log in a username. I'm going to go there myself. In fact, I think I already have a browser pulled up. So this is what you should see. So I'm going to enter the chat. Cool. So we got all these people in here. I'm going to get down because I can't reach the keyboard. So you can just type everything. You know, it's a chat. It works like a chat works. When you're looking for cross-site scripting vulnerabilities, one of the first things you want to do is typically inspect the page source. Because if they have any JavaScript that's embedded just within the page, if it's a really poorly written application like this one, you'll find your error just like that. And that was actually what happened here. The first thing, basic thing you can go do is just inspect the page source. And if I scroll down here, I see some JavaScript code that's just executing. They made this app with Socket.io and Node.js, and so let's see if there's anything wrong. And I go down, I look, and I see the socket.on function down here. The socket.on function seems like it's displaying a new message, so this seems like what's going to get called whenever I type a message in the chat. And I can pretty much verify that because this chat.append is appending my nickname with a bold HTML tag along with my message with a break tag. And that's what's happening here. There's a new line that gets created and your name's in bold. And so those HTML tags are getting executed, which tells me I have an entry point to put my own HTML tags in. And so we can play around with that just by entering, say, a header tag. And this will actually execute as HTML code. And if we want to play around with CSS even, we can. And this should all be executing on everyone's phone or whatever you're using. And that should be green, yeah. So at this point, I like to play around. Now that I know I can execute HTML tags, one surefire way to get across that scripting vulnerability, even if they strip scripting tags from you, is you can throw in an anchor tag and do a JavaScript on-click function, which is what I'm going to demonstrate here. This is what I like to call my little free beer exploit. This is great if a social media site, for example, has the ability to post custom links and they are vulnerable to cross-site scripting errors. You post an interesting link, like free beer, who doesn't like free beer? You click that link and it'll execute some JavaScript code. Okay, so from there, I'll see if I can just execute a plain script tag. So if you know any kind of JavaScript or any kind of how general web programming works, this is really simple. And I'm going to execute this alert. And this alert would pop up on everyone's devices. So you all should have just gotten that alert. So that's kind of how cross-site scripting works. Affects everybody's session. If I had wrote, I could have literally written any kind of JavaScript I wanted to in that script tag to do whatever I wanted. I could have made you redirect to a new site, download a malicious file, any kind of thing I wanted to do. This is just demonstrating just very basic how it works, how it affects everybody's session at the same time. So I'm going to get out of there, and once I'm out, I don't care what you guys do. At your own risk, talk, mess with each other, have a good time. So how do you prevent cross-site scripting? 99.9% of the time, you just got to sanitize your input. There's nothing wrong with manipulating the DOM with HTML tags as long as you don't have an insertion point in the DOM. For example, with this chat app, if they had just stripped the HTML tags and sanitized the input before you enter things, there wouldn't have been a cross-site scripting vulnerability. But what about that 0.1%? Well, you need to handle cookies properly. You need to watch out for insertion points in the DOM, and you don't just check your JavaScript, check your server-side code as well. And what I mean by all these things, if you are displaying data from cookies in your session that go onto the screen at some point for some reason, this is just a harebrained example that I came up with. If I go in and edit my session cookie to store string data that has maybe HTML code that I want to execute because I see that's just displaying my session cookie data, whenever I'm done with my session and it loads in that new data and displays it on the page, that's a very poor way to handle cookies, and my code will execute. So you probably shouldn't do that. Insertion points in the DOM. What I mean by this is you can, if everybody's ever played around with your inspect element, you have your console. You can also insert new HTML elements into the page. If you're able to execute code via either of these things that affect more than just your session, that is an insertion point in the DOM. Now, more commonly, you wouldn't really like go in and add a button into the inspect thing. You'd probably just go in the console, see if there's any JavaScript functions that you can run, and just run those and see if they affect anything. And then this one's probably the most important. Don't just check your JavaScript. Python, PHP, any kind of server-side code can all have cross-site scripting vulnerabilities. If you're posting stuff via PHP that's executing HTML tags and it's coming from data that a user's input, they can execute JavaScript through your PHP code. So don't just check JavaScript for cross-site scripting errors. Reverse engineering. Not actually going to do reverse engineering, guys. I suck at this. This is just kind of get you come here. Sorry, you can leave now. Obviously, I'm just kidding. Okay, terrible jokes. So why is reverse engineering important in games? This should be obvious. You can steal code and ideas, steal your games. Game piracy is rampant, especially on PCs. And you can find information, whether it's your server communications, how you're handling data. If you can find that in an application's binary, you probably wrote a pretty poor way to handle your information. But like I said, I am not very good at reverse engineering, so I wrote a very, very simple introductory dummy program in C to demonstrate how reverse engineering works. I'm not very good at assembly, but I know enough to kind of give an intro to people who may have never done this before, which is my full intent. So before I show you the source code, I want to actually reverse engineer it and show you how it relates to the source code, how I can walk through the logic of my program and then see how it matches up to the actual source code of the program. So I'm going to compile this program right here. And okay, how is that going? That's because I'm not in the directory.
Sorry, I hacked you.
All right, so we're good to go. All right, this program is real simple. Prints out x is 1, y is 2, z is 3. Easy as can be. Let's look at how this looks in a disassembler. You missed it. Ooh. Get out of here. So I'm going to be using the Hopper as my disassembler just because it's got a free trial and I can't afford a normal disassembler. Disassemblers are basically something that you can use to pop in a binary and it will try to generate the assembly code for that binary. If you don't understand what I just said, that means take a Windows exe file, throw it in this program, it'll attempt to generate as close to machine code possible as it can for you to try to figure out how the program runs. So that's what I'm going to do. This A dot out here is my binary for that program I just ran for you guys. And I'm going to pop it in my disassembler. And here we can see I have a main function. I know enough about assembly to read this, so I can kind of tell you how it functions. So this is my main. I know. What's up?
Can we make it bigger at all?
Nah, unfortunately, this can't go any bigger. I'm sorry, guys. Well, actually, maybe. Let me try. If it does, I don't know how, so deal with it. So we have right here a couple of things just going on, and we can see, I see these hexadecimal values here. These are really easy to read because that's just a 1 and a 2, but Hopper has this really nice functionality where you can change the values to decimal, so if you're really having a hard time reading hexadecimal code, starting out learning this stuff, it's just easy. So that changes to 1, 2. So I can see we're moving this 1 to this double word, we'll call it var8 to make things easy, and 2 into this varc. So we're moving those values. It's like assigning things in variables. And then we're moving var8, which is 1. You have to follow this line by line. into register EAX, which registers are a thing that you use in assembly basically to store data to do a lot of different things. In this case, we're going to do some arithmetic. So we're going to add var_c, which is 2, to EAX, which remember we stored 1 in. And that should give us 3, which will get stored in EAX. From there, we'll store EAX in what we'll call var10. And then we'll assign all these values to these other registers, which are then going to get called in printf, and then as the parameters, and then print it out. So that's basically how that's running. And this is very, very, very basic. And we can verify that that's exactly what this is doing by going to our source code over here and taking a look at this. And this I should be able to increase for you. Though I'm not sure how. Anybody know any fancy Sublime codes?
The Apple symbol? I think Command plus works.
Command plus works? Yeah, there you go.
Oh, he's got it.
Cool. All right. So literally, what I just described now, in assembly it's a lot more lines of code, but I assigned 1 to x, which is a variable, 2 to y, another variable, adding x and plus y, storing another variable, and then printing it all out. That's all the program does. And we were able to figure out exactly how the program works without seeing this code. That's the whole point of reverse engineering. So where's my slideshow here? So how do you prevent your code from being reverse engineered? So like I said, this is very basic. Say you have a very complex, huge game or something that you pop a binary and it's not going to look like that at all. It's going to be extremely confusing to look at, especially if you're brand new. I know I couldn't read it at all. But the truth is you really don't stop reverse engineering. There's not really a way to prevent people from reverse engineering your code. There are some different methods to make it harder, but the only real solution to keep people from reverse engineering your code is to write it as if you want people to see it anyway. That doesn't necessarily mean open sourcing all your code, but pretend that somebody who's going to be playing your game or something that you don't want access to information that's inside of your code, pretend they can see it. Write your game as if they can see it and make sure that nothing is too important that they shouldn't be seeing. That's really the only way, and that's really hard to do. But there are some methods to make things harder. Obfuscation is one of them. Obfuscation is what's called security through obscurity, which what we said was a very common phrase in the security world, which just means it's not secure. It just means it's a lot harder to read. It's obscure. So obfuscation makes things hard to read, but doesn't actually stop people from reverse engineering programs. You can break the debugger, which is actually pretty effective. If you write code and your disassembly output that is generated by the code can break GDB or can break the hopper when somebody's loading it into the program, that kind of slows down the reverse engineering process pretty heavily. So that is one thing you can try to do. I'll touch those last 2 points in a minute. I want to demonstrate code obfuscation to show you why it's not a good idea. It doesn't make things better, it just makes things a little bit harder. So it's not really secure, and I want to demonstrate that for you guys. So we have the same source code file over here, and I've got some more code below it that I've got commented out, so I'm going to uncomment that and recompile. But before I recompile, Before I recompile, I want to walk you through the program first so you understand how it works, so when we go through the disassembly it'll be a little less confusing, because this does obfuscate it just a little bit. Obfuscation isn't really anything more than moving values around in your stack, passing parameters, doing roundabout function calls. It just makes the code more complex than it needs to be. Whereas we had a main, signed through variables, printed out, it was like 4 lines of code, whereas this is at least 10, if not, maybe less. But so here we have our main, and our main's not doing anything except for calling this OBFS function, obfuscation function. Then from here, we're assigning variable x to 42, passing it into our final function. And we all know 42 is the meaning of life, so our final function takes in the meaning of life, and we do some pretty simple math here, assign it to some variables, do x plus z again, and then print all that out. So let's see what the output for that is. So we'll recompile this. It's the same. The program does the exact same thing, just in a weird roundabout way. And when we go look at this, the generated assembly output for this, pop in binary, it will be very, very, very different. So right here is our main, and we can see the main's calling this obfuscation function. I'm going to be very brief with this. I'm not going to go into too much detail, but just for you to get the point. Main calls obfuscation function. Obfuscation function's up here. It's doing some weird stuff. We can see what this value is. That's 16. Okay, it's doing something with 16. Oh, that's no, never mind, that's the normal stack. Don't worry about that. This is the value I was looking for. 42. So there's our 42 that we saw in our other program. And then from here, we're calling the final function. And it's doing all sorts of stuff. But I could actually follow through this. So I can see that we're putting var4, which is 42, into the register EDI. And then we're calling this function. And then we're doing some stuff with that. We're moving EDI and EDX. We're doing, moving EDI var4. We're doing stuff with that register. So that register value of 42 got moved. The value of 42 got stored in that register, and now we're doing stuff with that register in our next function, which will end up being how we do the math to get 1, 2, and 3 printed out on the screen. So that shows some obfuscation there for how much harder it is to read and follow along, but I could still figure it out. It's still not impossible. It just makes it just a little bit harder. So that's what I mean by it's obscure, but it's not actually secure. Okay, we don't need that anymore. Don't need that. And don't need that. So I want to touch on the last two things. My watch going off on me. Darn smartwatches. Okay. So we got the last two things are validating input and don't hard code anything. Validating input doesn't really relate to reverse engineering directly, but if your code, if you can find via reverse engineering or via just playing around with your program that there is some kind of buffer overflow error, some kind of way to spoof input of any kind, that can be dangerous for your users. That can be terrible just for your program in general. You don't want your program doing stuff it's not supposed to do in the first place. So make sure you always validate input. That's pretty much true across anything you're ever doing. If you take user input, validate it. Make sure it's correct. Doesn't matter if it's a application written in C. It doesn't matter if it's a web app that just takes in a couple form fields. Always validate your program. Doesn't matter. Or your input, my bad. The last thing is don't hard code anything important. This is how games get stolen. This is how software gets pirated. If you hard code your license check values and you're like, oh yeah, if they have lick.txt set to true that they have the correct copy of the game, you store it in some random directory. If they go find out where you're checking for that, they can just pop it in there and then bam, your license is compromised. This is a terrible way to do things. Same thing with in-app purchase values. If you're verifying, for example, if you have an in-app purchase on the App Store, if you're checking if the user ID has purchased such and such in-app purchase, and then from there you're saying, okay, check if this comes back true, then hey, they have it. You can spoof instead of saying, hey, they bought this. You can say, okay, this is true now. If you're assigning it some weird variable, if you're doing things weird, you can do all kinds of weird things where you can, reverse engineers can do all kinds of weird things where you just change in values as they're stepping through your program and end up compromising whatever it is that you were trying to check against, and they get it anyway. So don't hard code anything important. Always pull from server data if you can, or have things encrypted. There's not really, I don't know any way to do that. I've never had to build a license check. I've never done in-app purchases before, but I do know how easy it is to break things in the examples I've seen where you don't do it correctly. So I've seen all the how you do not do. I've never seen the how you do. So the next thing I want to talk about, and this will be kind of the final thing of my talk, is game hacking. I chose iOS as a platform that I'm going to hack. I chose it because people don't think of it as a gaming platform. It's not thought of that way, but it very much is. It's a very common gaming platform. Everybody's playing Pokemon Go now. Illustrates my point perfectly. It's a huge gaming platform. You got people freaking out about Flappy Bird and playing Candy Crush and all these other games that they play on mobile. So it's a large gaming platform. I also have my most experience as an iOS. I am dominantly an iOS programmer. When I learned programming, I first learned Objective-C for the purpose of developing applications for iPhone. So it's where I feel most comfortable. And it's fun to break something that people see as inherently secure. iOS is definitely a super secure platform, but many people have broken it many times, and it's fun to play with that because people are like, oh, it's more secure than Android. And I'm just like, yeah, but it's still 100% breakable. So it's just fun to do. And I got some neat little surprises. Okay, so what I'm going to do now is a simple property list hack using data that gets stored in NS user defaults, and this data that is stored in NS user defaults gets sent to the game center. All NS user defaults is a way to store save data in a property list in your local file. It's kind of like a cheap way to store things without using core data. So I'm going to demonstrate the game I'm going to be breaking real quick. This is actually one of my own games, so my own game that is currently published. You can go mess with this now, I don't care. It's called Stickman Joe Sky Surfer. This was one of my first games. I made this when I was like 17 or 18, just graduated high school. And I haven't touched it since then, so it's very old. This is the game. And you just fly around, you dodge stuff, and you die. The longer you last, the more points you get. There's two score systems. You have an overall high score, which is however long you last. And then you have this extra section where your total points that you accumulate will allow you to unlock different abilities and upgrades. And these upgrades will give you bonuses in the game, like slowing down the objects coming towards you. They'll deflect different, like one reflects rockets, one reflects everything. The master is you literally just cheat mode, like go through and nothing can hurt you. So that's what the game. And what we're going to be exploiting is actually this total points to make it appear that I have thousands and thousands of points. Now this is a little bit different because I'm not reading data from NS user defaults back, so I don't exactly unlock things across devices. But I do piss a lot of people off by changing my score and just wrecking everybody. So it's not that harmful, it's just really annoying. But I do want to demonstrate this principle for people who are storing data in NS user defaults because, for example, Flappy Bird was pretty sure one of those games, and that's how whenever you see people with 1 million points on that game, they didn't get 1 million points playing Flappy Bird, they cheated, and this is probably how. All right, so I'm going to show you how to do that. I have over here on another device, jailbroken iPhone 4S running iOS 7. If it'll show up. There we go. I have the game over here. I'm not going to show it to you on here. It works, but when I go to the extra section, it crashes because thank you, new compiled code on iOS 8 and 9. But I can still demonstrate the point. So I have iFile here. iFile is basically a file explorer if you have a jailbroken device. And you can explore all your system files, including your apps. And so I'm here in my preferences of my application where I see this property list that's getting stored. And iFile has a wonderful property list viewer that just takes me right into what I want to see. And, oh, total points saved. High score saved, launch count. All these are values that are getting saved in NS user defaults that I can just mess with. So I'm going to change my total points saved to, say, 100,000, or however much that just put in, I don't care. And now that that's in there, I run the app. All that data, woo, that's fire. I don't know how to turn that down, but that's good enough. So all that data right there should have just got sent to Game Center. And if I restart my app and switch my inputs, so everybody's not confused, then I can go into Game Center, and I should be able to see where I've given myself 1 million points. So that's how that works. It's really easy to do. Edit some plain text, and bam, got 1 million points on my game. So this example isn't really detrimental. It doesn't hurt anybody. It just makes users mad. But if you were storing more pertinent information, such as a license check, or not a license check, some kind of validation for unlocks or something that maybe you normally have people pay for, that's a way to get around it. There's other ways that people hack things on iOS, especially if it's a developer for a jailbroken phone. And this is important because you don't have to have a jailbroken phone for this to affect you, especially if you're the game developer or the app developer. It can be any kind of software. Jailbreak developers, and whether they're malicious or not, have the ability to write things called tweaks. And tweaks are changes to existing functionality in iOS, whether it's a system hook or a tweak to an application such as Snapchat. You can hook into an application and change its functionality. And that's how they do this, is a method called hooks. I'm going to show you an example of a hook. So here you have the basis for hook syntax. It uses a mixture of what's called hook syntax and Objective-C++ syntax. Here we're importing our Springboard header file. We're hooking in the Springboard, that's the hook syntax. And then Apple has all these delegate methods. For example, one of the application did finish launching. So we're going to call the original function of the Springboard, and then we're going to do some stuff after it. So the Springboard is going to function just like it always should, and then we're going to execute our own code. And what this is actually going to do is once your phone were to unlock or be presented with the lock screen, actually, an alert will pop up and say, hey, welcome to your iPhone. And you say, okay, thanks. And everything functioned as normal, but then you could run a whole program from this at this point if you wanted to, just by hooking in the system. So that's an example of a tweak using hooks. So tweaks can do pretty cool things. You can save other people's Snapchat photos and videos without them knowing. Flux was a cool tweak before Apple stole it and made Night Shift. Changing UI layout and changing controls and button functionality. On my iPhone 4S, I have my lock button's actually broken, so there's a cool tweak called Activator where I can set different buttons and gestures to do functionality. If I hold my status bar, it reboots my phone. If I shake it, it locks. It's pretty cool. But they can also do pretty illegal things as well. You can use them to pirate apps, steal in-app purchases, ruin game scores, similar to NS user defaults, and there's cheating video games. And we're talking about video games here. You can use them to cheat out the butt. You can steal all your fancy little hats and stuff that you're selling in your game, and you can, more importantly, if you've got an expensive game, so you're selling a $5, $10 game on the App Store, they can just steal it. It's really easy to pirate games and stuff on iOS because they have scripts and programs that other malicious software writers have written where you just pop into that binary and it tries to crack it for you, and most of the time it works. So how do you stop people from doing this? Write really good, efficient, complex code, confuses the little dudes who are just popping things into this program. If an error comes up, these little guys won't know what to do. There's all these little 10-year-olds that have their jailbroken iPhones, and they're like, oh, I'm going to crack your app, and they pop it in this command line tool, and it gives them errors, and they don't know what to do. But the more experienced guys, that really won't help with. Again, you have obfuscation, if it helps. It helps a little bit more on jailbroken devices, because one of the methods you do is you try to probe the methods of an application as you're stepping through it to see what they return. So if your methods are doing weird callbacks, the probing is going to return unexpected values to you that you're not going to understand how the methods actually work. So it does kind of help a little bit more. But again, security through obscurity, not secure. The surefire way you can do things is by detecting a jailbreak, but you've got to be careful with this. Jailbreakers are legitimate users too. I enjoyed a jailbreak my device because I liked to be able to do system level things with it, but that doesn't make me a pirate. That doesn't make me a bad person. I'm not necessarily stealing software or anything like that, but there are people that do. But there's a lot of jailbreakers in the community that are perfectly legitimate users, and you shouldn't block them from using your software just because they have a jailbroken device. That's their freedom of choice. But there are ways to detect if there's pirated software on the phone, and there are ways to check if your app specifically is pirated on the phone. If you have code written to perform these detections, that can be a little bit better way. I would recommend more so detecting your app specifically, because if you just check for pirated software, even a person pirating general software, that doesn't mean they didn't they stole your app. They could have legitimately bought your app and just stole some other apps. So, if you don't care about the competition and you're getting money anyway, there's no real reason to stop them. So the surefire way is to detect your app being pirated. So if you have checks in place that get around all the tools and stuff that are written, that's probably the best way to go about that. Okay, so in conclusions, the things I want you guys to take away from this talk: sanitize your input, especially for cross-site scripting. Verify everything. Just everything in general. I have cross-site scripting, buffer overflow, all this, but just anything. Verify all your data that's getting sent. Manage your data securely. Test everything. If you think there may be an error, if you don't think there may be an error, keep trying to break it. Always test it. That's important. Obfuscate if it helps. and always write secure code. I want to throw out a couple thank yous. Team Sneck in our route, that was our third place team that we went to General Electric's Ghost Red competition, brought home third place. That was Bob, Nate, and Chris. I wouldn't be anywhere without these guys in cybersecurity. They've taught me so much, and I wouldn't know anything in this talk if I didn't spend a lot of my time with them. I want to thank Frank and Aaron for the cross-site scripting demo. Writing bad software helps me. Georgia Game Developers Association for letting me speak, and all of you for coming to my talk. So now you have some new knowledge on how to hack some stuff, so go break some stuff. Just make sure you fix it afterwards. And I don't know how much time I have, but if there's time,
We got about 11 minutes.
Okay, cool. So anybody has questions, I'll take questions. What's up?
I have a comment and a question. The comments on hard coding anything in there. So, funny story, one of our first games called Battle of Destiny, this is the early 90s. We give it to the publisher, we have no protection on whatever. No protection on it, anyone can copy it freely. And the publisher explodes, says, no, you gotta put something in there, at least purchase verification code, which is where you send people to a page in your manual, and they would have to type out a specific word from the manual in order to get the game to run. So we put it in there mainly, and we did it in such a way that created a second game because we were all hackers. Everyone we knew was just going to go in there and hack the games in order to get the codes. So we were launching 2 games in one. But the funny part of it is about 10 years ago, we put the game up for free on our website, and I didn't have the manual. I didn't have any of the old information. I didn't want to spend any time going back through the code to get all of the old purchase verification codes. So in order to put this up online, I actually just contacted one of the hackers I knew had hacked the game, and sure enough, within minutes, he grabbed a file of all of our purchase verification codes, emailed it to me, and we posted that with the game, and we put it up online. So yeah, hard coding the information is not a protection, but it can be a fun game for the hackers. The question is, you've obviously had some dealings with data security as well as data integrity. So one thing I see game developers often do poorly is even when they're not capturing information like credit cards online, they're often capturing a lot of other information, most notably usernames and passwords, and then not doing a good way of securing that well on their website and keeping that information up on their website. Any other specific advice on how to manage that sort of data?
Yeah, so there's 2 issues you have when sending data to different server communications. I know one example, we could have absolutely wrecked all of that one CTF I was referring to, Ghost Red, because they didn't filter their data that was coming into the scoreboard. So we just saw the codes that pull up a Wireshark and just scan the network, and we'd see all the codes that are coming in and they're sending out valid, invalid responses. So we can just collect all the passwords, type them in, get our points, and win the game. So they didn't encrypt their data, they didn't hash it or anything. So one important thing is when you're sending data, make sure it's encrypted, make sure it's secure. The other thing is once that data is stored, don't store it plain text. That should be obvious. But most importantly, make sure your database is secure. If you're already encrypting your data or hashing it or whatever means of security that you're going through, putting the data on the table, if you're doing that, also make sure your database is extra secure. All your precautions in place, your user privileges, anything like that. Because if I can get base level access and you're using a really crappy database, I can then escalate my privileges and then just corrupt your whole database or get information out of it. And corrupting the database is just as harmful as stealing usernames and passwords. Because if you can't use your database, your whole program is shut down. So that's my advice there. Anybody? Cool. Well, I'll be here.